Oh, yes. It's Brady.
Caw.
And Levi.
Levi.
Do the bird noise.
Caw.
Caw.
Nerdish.
It's nerdish with a 3, not nerdish with an E. Why?
8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Yes, because nerdish with an E was taken.
And that's why we do it 8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Thank you for giving that reason for a question that I didn't ask.
That's sort of like the way we eliminate answers on the reading section.
Yeah, that's true. And I guess the other sections to a certain extent.
I think it's important when doing a rap to listen to the beat that's happening in your ear. Otherwise, you have a problem staying on beat.
Correct. We do the ACT and SAT, they're standardized tests to help you get into college.
We don't tutor rap. We shouldn't ever do that.
No, we're not pretending to be tutors of rap, even though we're really good. Sometimes you can be really good at something, but not be a good teacher. Case in point.
Point in case.
Point in case word.
Point in case something bad happens.
Like this?
Yes.
I think we're enriching your lives by you watching this.
I'm getting a phone call from a friend. Do you think I should pick it up now?
The phone call just was dropped. Maybe he'll leave you a voicemail.
Next time, I'll pick it up during the stream. That way we can all talk to my friend Steve.
If you think this is not very high quality, don't worry. We're gonna do it again in 2 weeks.
Also, we're much better quality when we're teaching you all the things in a number tree.
Like prime factorization?
Yeah.
Oh, that's fun.
Yeah.
You break a number down into its prime parts until you can't break them down
We
anymore.
can probably do that right now.
Yeah, we might.
Okay, so let's say 32.
I was going to say 30. That's so close.
Oh my gosh.
All right, break it up.
Okay,
Any way you want. 2 and 16.
Okay, 2 and 16.
2 and 16. 16 is 4 and 4.
Okay, 4 and 4. Oh,
And
interesting.
each
So
4
16
is
the perfect
2,
square.
2. Yeah, exactly.
Okay, 2 and 2 and 2 and 2.
So it's 2 to the 5th.
Yeah, it's 2 to the 5th.
2 to the 5th, exactly.
Whoa.
Yes.
That's pretty cool.
You see that? It's that quick. Now you know. Think about that for our whole show.
Now stop watching the stream because you've learned everything necessary.
Bum, 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 bum. We're in a box. You can help us by asking us questions in the hope that someday we can escape. Okay.
Hello.
Look who's here. It's everybody.
And it's us.
The two of us.
Everybody. Well, most people aren't.
True. Yeah, no.
Yeah.
Yeah. By a pretty big majority.
Right, but...
What? There's a whole... I don't know. There's this comedy bit about how most people are not here right now. But I'm not going to get into that. Levi is now here because he missed the cram session and he left me on my lonesome. He let me out to dry. And I talked about how he left me out to dry, and I was very, very dry.
And you were much drier when I came back.
Right, because you left me out to
Because
dry.
whenever I take you out, you jump in puddles, and you get your fur all wet.
No, normally you take me in, and then I get, I get all wet again. And
I
then
would never take you in.
If you left me out, that's when I get dry.
Hey,
Okay.
Stream Elements.
Hey, look at that. All right, today's a really big day.
Huge
because it's another day of life, so that's huge.
Yep.
And
Days don't really have size.
That's
The unit of days is in time.
right.
But I guess space and time are relative.
There you go.
So,
That's why today's a big day.
yes.
We're talking about probability. The likelihood that a given event will happen or not happen. Very exciting. Very exciting. We're going to start it off real easy. Okay? Real easy with just some dice. Just some dice. Or rather, one die. All right? And then we're going to get into some actually really tricky probability with combinatorics and things like that. So get excited because I'm excited. So there we go. Maybe we got, I'll just show the 6 one right there. We got 6 pips on that. I think they call them pips, okay? So the normal equation for probability is desired out of total. What that means is how many outcomes do you want and how many total outcomes are there, okay? So let's think about certain outcomes here. We roll one die. The probability that we get a 4. We don't put a 4 on top. It's not like we do desire a 4, but that is one outcome. We only want one outcome, and there are 6 total outcomes. So the probability of rolling a 4 is 1/6.
Why not 3, my lord?
Good question. I don't know. That's a good question.
Yes.
Okay. In fact, the probability of any number rolling 1 through 6 is going to be 1/6. There are 6 equally likely options, so yes. What about the probability of not 4? How many outcomes obey not 4? Well, 1, 2, 3, 5, and 6. There are 5 options. So 5/6. Now you should notice something here. All probabilities of some situation should add up to 100%. So the probability of 4 and the probability of not 4, you're either going to get one of those two things. So those together need to add up to 100% because one of those is going to happen. Brianna Whitley. Yay! We like Brianna Whitley. Thank you, Janelle. Mitzel Santoyo. That's very nice of you. So
I think she's calling you Brianna Whitley.
Oh, maybe she's calling me Brianna Whitley.
Clear that up. That's not who you are.
Right, I'm not Brianna Whitley. Maybe that's what the confusion is.
Yeah.
I used to be Brianna Whitley before the accident, and I no longer am Brianna Whitley.
Okay, you cleared it up.
Anyway, so one of these things is bound to happen. You're either going to get a 4 or a not 4. So they add up to 100%. The one chance that you don't get one of those two options is the chance that is ever present that you get nuked, that a nuclear bomb falls and everything's gone right as you're rolling the die, so there's not an outcome. But it hasn't happened. It has happened to certain people, but we're not going to get into that. Let's just assume that we will not get nuked and time will continue as we expect it to, and the Earth will continue and all that stuff. All right. So the probability of some event. So we're going to call that probability of A plus the probability of not A. There's a notation for that, which I'm not getting right now, is 100%. So there are some probability questions where they ask you, what's the probability of this happening? And it might be very difficult to calculate, but if you can calculate what the probability of it is not happening going to be, my sentences aren't sounding good. If you can calculate the probability of that event not happening, then you just subtract that away from 100% and you'll have the probability of that event actually happening. Sometimes it's simpler to do that. Fantastic, okay? Now we're going to move on a little bit, which means we're going to have a new marker. That's what we're going to do. Okay. Oh, no, I haven't used blue yet. I haven't used blue. Okay. Probability of a 4 or a 5. Those are 2 outcomes out of 6, 1/3. When you see or, that means that there are multiple outcomes that satisfy what you're looking for. So what you do is you add the probabilities together. So this would be equivalent to probability of 4 plus the probability of 5. And that's 1/6 plus 1/6 is equal to 1/3. Okay? So or, one thing or another is going to be plus. All right? So there's that. And then there is the and then possibility. I like to call it that. They don't usually call it that. All right? Here's the question. P of 3 and then 6. All right? So this means there's 2 separate events. We want the probability of first getting a 3, rolling it again, and then getting a 6th. Okay? When you see and then, you're not usually going to see and then, but when you see one event followed by another and they want the probability of both those things happening, that means you multiply. So this is going to be the probability of 3 times the probability of 6. And that's 1/6 times 1/6 is equal to 1 over 36. That's a pretty small probability. Why do we multiply there? Why does that make sense? Well, think about all the different possibilities that could happen. All right, on your first roll, you can get a 1, 2, 3, 4, 5, or 6. From each of those rolls, there are 6 further possibilities. So you can get another 1, a 2, a 3, a 4, a 5, and a 6. All these 6 branches are coming out of just the 1. Every single one of these original numbers has 6 branches coming off of it, meaning there's a total of 36 possible branches or 36 outcomes. So the one that has 3 and then 6 is just one branch out of a total of 36 branches. That's where the 36 comes from, as we multiply every number times 6 of the numbers that are after it. So we get 36 options. All right? Very good. So or means and then means multiply. Very good. Very good. Now we're going to get into the wild stuff. All right? It's going to be pretty wild. It might rock your world. It might not. This is going to involve some combinatorics, so combinations and permutations. And if you are not well versed in either of those, speak up and we can talk about them before we dive into this stuff. And dive into it we will. And hopefully the bottom is deep enough so that we won't hit our heads. Because that happens sometimes. Levi, do you ever dive into a pool that's too shallow and you hit your head?
Yes.
Like all the time?
Yeah.
Really?
Yep.
You do that this past weekend?
I did twice.
Twice?
Same pool.
Same pool?
Yeah, different
Same
head.
day?
No, different head.
Different day. Different head?
Different head.
Oh, you got yours replaced?
Yes.
Got it. That makes sense. That makes sense. Gee, I hope Brianna Whitley is watching. Because Janelle Midzel Santoya really wants her to watch. I think Brianna, did I say Brittany before?
I don't know what you said.
I hope I said Brianna. I think Brianna would get a lot out of this. But that's
what I've
just
heard.
me. Yep. Okay. There we go. Is that for me or for you?
Nope. For me.
Got it. Hello, this is Levi at Nerdish. Can I take your message feed
Maybe we should have people just call our personal phones
during our stream?
asking us questions.
All right, we're getting down to the hard stuff now. It's going to take everything you got. All right. Here we go. Here we go. So we have Beth and Shayna. And they each buy one Raffla ticket. It is a Raffla. It is not a raffle. Okay. Total of 11 tickets sold. Probability they both win. Probability that they both win. Okay. So, is this one event or is this multiple events? Well, it's multiple events. One of them is going to win, and then the other one is going to win. So, we want to use and because we want to multiply the probabilities together that they're going to win. They're not picking all the tickets at the same time. Maybe they are, but we can think about them reading the tickets one at a time. So the probability of one of them winning, followed by the probability of the other one winning as well. Okay, so we would break this up into probability of Beth wins times the probability of Shayna wins.
Nice.
Now here's the interesting thing, though.
Shayna's my daughter.
That's not true.
Oh.
That's not true. Here's the interesting thing. These events depend upon each other. They're called dependent events because as soon as you take one ticket out, when you choose the next ticket, there's not as many tickets left in there. So we have to think about that when we do this. The probability of Beth winning, she has one ticket out of a total of 11 tickets. So that right there is going to be 1 out of 11. All right? Now let's assume she won. Let's assume that she won. Wait, how many are selected to win? That's kind of important.
3 million?
Maybe. 2 winners will be selected. I'm sorry, that's important. Okay. Two winners selected. If it was only one winner selected, there's no way they could both win. That'd be a probability of 0. Great. Okay. So the chance of her winning the first time, they have to pick her ticket, which is 1 out of 11. And then the chance that Shayna wins. This is a new event. Her ticket is 1, but it's out of 10 because we already picked one of the tickets. So 1/11th times 1/10 will be equal to 1/110th. Let me make sure that that is right. Because if it is not, then we have a problem. You might say, shouldn't you already know if it's right? And the question is... Somehow that should give us... Oh. Oh, man. Oh, man. Oh, man. Oh, man. Okay. Okay. All right. You'd think that this is how it would work. And this is, in fact, the probability of Beth winning followed by the probability of Shayna winning. But there's another possibility for how they could both win, which is Shayna gets picked first and then Beth gets picked. Both of them would satisfy them both winning. So while this will solve for this one order of them winning, I'm actually going to erase this back up a little bit, and we're gonna do this one more time. Yep. You make mistakes in math. All right. The only person that doesn't make mistakes is Levi, and even he makes mistakes.
My lord.
What?
If the answer is 3, my lord, no mistakes.
Ah, good. Good, good, good. This is gonna be fun. I told you guys this is gonna be difficult. Difficult probability. We got to take a much bigger picture here. Huge picture. All right, a lot of pixels in this picture. Where am I marked? Did I put it in my pocket? Why did I do that? Okay, the probability of them both winning is going to be the probability of Beth, then Shayna.
Oh, hello, Small.
Oh, Henlo. Or Shayna then Beth. I guess I should be consistent here. These would be and then. That's what I used before. Okay. So this is almost like using parentheses. Beth and then Shayna is in its own set of parentheses, and then Shayna and then Beth is in its own set of parentheses. So the first thing we have to do is think about this or. Or means and. So let's rewrite this into two separate probabilities with an and between them. So the first probability is probability of Beth.
Hey, you just said or means and. I don't know if that...
Did I mean that?
I'm
sorry.
Sort of, but...
Or means plus. You're right, I did say. Maybe did I say or means add?
It sounded like and.
If it sounded like and, that's a problem. Yes. Yeah. Or means add. So the probability of Beth then Shayna plus, that's our or, the probability of Shayna then Beth. All right. Now is where we put our probability together. So Beth and then Shayna means multiply. Shayna and then Beth means multiply. In both these cases, the chances of the first person winning is 1/11th, followed by the chance of the second person winning 1/10th. Same with the other one, 1/11th times 1/10th. And we're adding these things together. So we have 1 over 110 plus 1 over 110 is equal to 2 over 110, which can simplify to 1 over 55. That is the probability of them both winning. Woo! Okay, that's fun. It's a lot of fun. We like that a lot. All right, let me know if there's any questions. Otherwise, I will go on to the next one. And it will also rock your world and possibly mine, like this one did. You just saw someone get their world rocked. All right? Okay, that's not a question. Good. Okay. The small. Did we figure out what that meant, Levi? Was that small elf or something?
I know he said he made it up.
He made it up. Got it. Got it. Levi, I know you don't watch a lot of TV. Do you watch Game of Thrones?
I did not watch Game of Thrones, but I do watch it. I just didn't watch the last episode.
Oh, okay. Got it. Yeah, well, that's good. You watch some TV.
Did you watch it?
Yes, I did.
How was it?
It was good.
Yeah, nice.
Yes. When you play the Game of Thrones, you win or you die. Yay. It's crazy. They have these royal families that are constantly competing and killing each other. And like the rate that they kill each other there wouldn't be royal families. I mean, they would all be decimated like in like the course of like 5 years if this show is portrayed. But I think it's a particularly turbulent time, which is why it's all happening like that. It's like Robert Baratheon, and then Robert's Rebellion. All right. Number 2. Oh, this is going to be fun. All right. So we have a meeting between a diplomat. You know what? We're going to put some fun to this. A U.S. Yep, there we go. A USA diplomat. Colors are worth it. And 14 government officials. Okay. However, 4 of the officials are Soviet spies. Because this is happening in the, I don't know, the mid-60s or something like that. 4 of the officials are Soviet spies. Okay. So, diplomat gives secrets to 10 officials. Question is, what is the probability that secret was not given to Soviet spies? Okay. Oh, I'm excited about this.
That's a pretty, serious infiltration.
Oh, yeah. But remember, there's a probability that secret wasn't given to the Soviet spies. It's going to be a very small probability because that's, you got to get 10 out of 10 right here. And to be able to get the 4 that are out of it, you got to be very lucky here. Anyway. Okay. Probability that's not given to the Soviet spies, there's 4 of them, is equivalent to, it's the same thing as saying the probability that the secrets were given only to 10 good guys. Not that Soviets weren't good guys, but they were on the other side. That's it. All right? Think about that. It's the same thing. Probability that we did not tell the bad guys would mean the probability that we told only the good guys. All right? Let's think about that. This is going to be a secret you're going to tell a bunch of times. Okay? Just like before when we had like Beth wins and then Shayna wins. This is you telling a secret to one person, hoping that that person's a good guy. Then you telling a secret to another person, hoping that person's a good guy. All right? So, let me think about this for a sec. Okay. The probability that you tell it to the first person, could be a man or a woman, and that they are a good guy or girl, guy or woman or whatever. There's 10 good people out of 14 total. All right? So right here, we're going to mark down first person, second person, third person, fourth, fifth, sixth, seventh, eighth, ninth, 10. The probability that the first person you told it to is a good person is 10 out of 14. All right, given that, so we're going to assume that that happened. Probability that you told it to the next person who was a good person, there's only 9 good people left out of a total of 13. And then there's 8 people left out of a total of 12. You see what's happening here. 7, 6, 5, 4, 3, 2, 1, over 11, over 10, over 9, over 8, over 7, over 6. The last probability is going to be 1/5. You got 5 people left, only one of them is a good person, so it's going to be 1/5. Okay? So let's see what we have here. This would be 10 factorial on top because we'd be multiplying all these probabilities together. All right? Now there are some cancellations we can make without having to put this in the calculator yet, all right? Think about the things that we see on the top and the bottom. So 10, that's on the top and bottom. So I'm going to cross this out. We have 10 and 10, done. 9 and 9, 8 and 8, 7 and 7. That just looks like a normal 7, so let me put another one through here, okay? 6 and 6, 5 and 5. So what we have here is 4, 3, 2, 1 over 14, 13, 12, 11. The 1 doesn't really matter. We can do a little bit more simplifying. I really do like simplifying here. So 4 over 12, that is simplifiable. If you take 4 and divide it by 12, you get 1/3. So I'm going to cross this out, and I'm going to cross this out, and in its place I'm going to put a 3 down here. All right, that's what's left after we perform that division. Now we have a 3 on top and a 3 on bottom, so those are going to go by the hoist side, so that 12 is officially gone. So we have 14 times 13 times 11, 2 times 1 on top. The 1 doesn't matter, so I'm just going to cross it out. We have 2 over these numbers. This number is even, so I can perform that division, so that's going to be 2 over 14 is going to be 1/7. So what we have at the very end, 1, because that's, you know, if everything's gone, there's still a 1 there, times, we have 7 times 13 times 11, which is going to be, I believe, it should be 1 over 1001. Make sure that 77 times 13, 21, 21, 22, 23, 7. Yes, 1001. Okay. Which is such a small probability that you can be pretty confident here you're going to tell the secret to the Soviet spy. And hopefully it's not the nuclear codes. I don't know.
It probably is, though.
It probably, yeah. What other secrets are there in the government? Just nuclear codes. All right. That was a fun one. We all like that. Let me know if you want me to explain any part of that. Otherwise, I'm going to erase this. And, I don't know, Levi, can I do one more?
Yeah.
Okay. Sweet. Speak now or forever hold your peace. I'm going to erase it. I will erase this. I swear.
Don't.
I'm going to do it.
Don't.
Wait, really?
No, you can't.
Okay. Ha! Ha! Anyone here take the... Oh my god. Thank you.
Was that too loud? I tried to make it as soft as possible.
Just loud enough. I don't know why I didn't look at you. Just to see what was going to happen. Thank you. Why don't you put it in the microphone? I think the kids are going to love that.
I think it's probably loud enough this far away from the microphone.
Can you play Havana? Here we go. Yeah, there's no way that person was able to do it. They used auto-tune.
Yeah.
Hey, thank you.
They did very well on their SAT, though.
You think so?
Yeah.
Nice.
If you hear a chicken scream enough, a basilisk dies, but also you do better on the SAT.
Yeah, that makes sense.
Not on the ACT, though.
Right.
Whatever you're saying, Bird, doesn't make sense to me.
Yeah, sure. Absolutely.
You
Here
got
we
one
go.
more?
Okay.
Where are these questions from?
Kuta software.
Kuta. Kuta software.
Barracuda. Da 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 da. Da 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 da.
Did you watch the other side of the board?
Not in a while. Do you feel that, or is it on the other side?
There's something on the other side. You see that?
Geez. Yeah, I see it. I'm not blind. Blimey. I'm not blind. I don't know. Just having fun with it. Trying to be a goob. A little goober. All right, so we have a fair coin is flipped 10 times. All right, what is the probability of getting exactly 6 heads? No more. Now, yeah, I probably should put the question mark after that as opposed to inside. The probability of getting exactly 6 heads. No more, no less. Well, a lot of times it's good to know how many different total outcomes there can be. Okay? So you've got a bunch of events here, and each event, you got 10 events here. So this event, here we go. These are the rolls. We got roll 1, roll 2, 5, 6, 7, 8, 9, 10, 3, 4, 5, 6, 7, 8, 9, 10. And each of these rolls, there are 2 outcomes, heads or tails. So there's 2 possibilities for each one. I call this the slot method. We got a bunch of slots here. Each slot has multiple possibilities in there. There are two possibilities in each slot. So if you want to find out the total number of possibilities, you just want to multiply all the different slot values together. Now these are not fractions. Let me make that clear. So let me maybe let me box these in. Otherwise these look just like fractions, and I don't want you guys to get that impression.
Okay, I'll box them in. You can keep talking.
No, I want to box them in.
You can't.
Great. Okay. So to figure out how many total possibilities there are for outcomes when you flip a coin 10 times, we're just going to multiply all these together, which is going to give us 2 to the 10th. 2 to the 10th, because it's 2 times itself 10 times. All right. 2 to the 10th, Levi, what is that?
2.
I believe that's 512.
200. No. 20
1,
million.
2, 4,
No, 20
8,
billion.
16, 32, 64,
I'm doing 10 to
128,
the
256, 512.
Yeah, that's what I said.
That is not what you said.
What did I say?
You said 10 billion?
I think it said 20 billion.
Where did that come from?
I think it was 2 times 10 to the 10th. That's what I was doing.
Oh.
Yeah.
Well, that makes sense.
What were you doing?
I don't know.
Okay.
I don't know. All right, now here's the hard part. Okay? Here's the hard part. We have to figure out how many different ways we could get exactly 6 heads. So I'll show you a couple ways. I mean, let me show you one way we can get 6 heads. We can get one there. Let's get one there. Maybe one there. We get one there. That's 4. This one. And I don't know. Let's say we had a nice streak here. Okay? There's 6 heads. Do you realize how many different ways you can get 6 heads? There's a lot of them. You can reshuffle these all sorts of ways. Okay? So the question is, how many ways can you select 6 rolls out of 10? Which is a combinations question. The order of the heads, they don't matter. If you're going to pick 1, 2, 4, 8, 9, you don't get to order those around again and make, oh, let's do 8, 4, 9, 5. No, we're just picking 6 objects out of 10. We're trying to figure out how many different groupings of those objects we can make. In which case, we're going to do 10, choose 6. 10, choose 6, which is going to be 10 factorial over 6 factorial times 4 factorial. You don't need to understand why this is the case. Just know how your calculator, it has the choose the combinations function in it. So just know how to use that, and this will do it for you. So this is going to cancel out a little bit. We're going to have 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. Simplifying time. We like that. 9 and 3 out of there. We got a 3 on top. 8 and 4 out of there. We have a 2 on top. 10 and 2, we're going to have a 5 on top, and the 1 down there doesn't matter. So we have 5 times 3 times 2 times 7 over 1, which is going to be 15 times 2 is 60. 60 times 7 is going to be 420 out of 1. All right. There are 420 groupings of 6 we can make out of these 10 objects.
Wait, it's 5 times 3 times 2 times 7?
Yep, what is that?
I think it's 210, not 420.
Wait, 5 times 3 is 15, times 2 is 30. Oh, you're right. You're right. Ah, jeez.
Dude, we need to stop the stream.
Why?
'Cause.
Yeah, right. Okay, so now we get back to our standard equation for probability. Desired out of total. There are 210 desired outcomes over a total of 512 outcomes. We can simplify because they're both even, so this is going to be 105 over 256. And if I'm not mistaken, I think that's probably the most simplified way to do it. Let's see. Yep. Wait a sec. 105 over 512. 105 over 512. Huh. Huh. Oh, wait a second. Levi. Okay, this question is rocking my world. Here, we forgot to do this. What? Forgot to do this. I got this. Let's talk about this one arrangement that we found right here. What's the probability of getting that arrangement? Well, the probability of getting a heads here, that's what you want, is going to be 1/2. The probability of getting a heads here is also going to be 1/2. If we don't get a heads here, that means it's a tails. So that means right there, we get a tails. What's the chance of getting a tails? It's another 1/2. All right? Each of these probabilities is going to be 1/2, whether it's heads or tails, to get this exact order of heads and tails. So the probability of getting that exact order is going to be 1/2 times 1/2 times 1/2 10 times. So it's going to be 1/2 to the 10th, which is going to be basically 1 over... That's not what 2 to the 10th is.
Sure it is.
No, it's not. It's 1 over 512.
20 billion.
1 out of 512. Because it's 1 over 2 to the 10th. And maybe I should put that step in there. 1 over 512. All right. So each of these options has a chance of happening of 512. 1 over 512. There are 210 of those options that we could construct, and each of those has a 1 over 512 option of that happening. So now we want to think about OR. This is an OR problem because we could get the probability of this, and that satisfies our 6 heads, or we can get a probability of a different grouping of 6 heads, or a probability of a different grouping of 6 heads. It's a ton of ORs, which means we're going to add all these probabilities together. All right? So the probability of getting this particular grouping of 6 is going to be 1 over 512, but there are 210 of those possibilities. So we're going to multiply this by 210. All right? Let me think about this. Yes, exactly. That's going to give us 210 over 512, which we can simplify here. It's a telemarketer.
Hello, this is Levi with Brady's phone. Who is this? Yep, they hung up.
Oh, so they thought it was me or you?
Yeah.
Great, 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 great. All right. So each of these possibilities has a 1 over 512 chance of happening. We multiply it by the fact that there's 6 different ways we can do this. Make sure that we have this right. Okay, 10 times 9 times 8 times 7 over 4 times 3 times 2, 1. So 1 over 3 is 3, 8 over 2 is 4. No. 10 over 2 is 5, 8 over 4 is 2. 15 times 2 is 30, times 7 is going to be 210. All right, so times 210 is going to be 210 over 512. All right, all right, all right. Is there something I'm missing here? Because actually, that's the same thing that I got the first time. 105 over 512. It should be half of that. It should be half of that. Why should it be half of that? There's one thing I'm missing here, and it's driving me crazy. Levi, can I get your help on this?
Yeah, okay, so what's the deal?
A fair coin is flipped 10 times. What's the probability of getting exactly 6 heads?
Okay.
All right. So there's going to be a total of 512 possibilities here of orderings. 2 to the 10th. 2 options for each one.
Okay.
So 512 total possibilities.
Yep.
And we want to choose the ones that are just strictly 6 heads. So the chance of getting this possibility, for example, these will be tails right here. Tails, tails, tails. That exact possibility is going to be 1/2 to the 10th anyway.
Mm-hmm.
That one right there. So that's 1 over 2 to the 10th, which is 1 over 512. All right. But the question is, there's a lot of different orderings we can get of 6 heads.
Yeah,
So
I think you're doubling up.
how would I be doubling up?
Well, you already have. So what you're doing is you're just saying there are 512 possibilities. So the way you're solving this, are you doing desired over total?
Yes.
Then you shouldn't be multiplying each of the desired by their probability.
Okay.
Right?
Yeah, no, I got the same thing in both situations, though.
So you did 10. You should have done 10, choose 6, right?
That's what I did.
So,
I mean, maybe I got that number wrong. Let's grab a calculator. I don't know how this calculator works. Okay, where's, do you know where probability is? No, here it is. No. Combinations. So we have 10, choose 6. 10, comma, 6. It's 210.
yeah.
It's 210.
What's the answer to this question?
It's half of this. It's 105 over 512.
Because you can either do this for heads or you can do it for tails.
Yeah, but then it would be 10 choose 4. It'd be the same exact thing. They're opposites of each other. You're still going to get 210. May I miss this probability?
Yes,
problems.
Eric, this is true. But
Yes.
this is way harder than anything on the SAT. So it would have been earlier in the stream. So you can check it out later. We are at the moment having trouble with this really hard one.
2, 4, 8, 16, 32, 64, 128, 2,
Wait.
56, 5, 12. 1024!
Yeah, that's what I was just going to say.
Oh my gosh!
You did that wrong.
Oh my gosh, it's 1024.
Yeah.
Okay. 2 to the 10th is 1024. This is, oh, yes. So, okay. This originally was 210 over 1024. There we go.
Dude.
I didn't know.
Eric, how are you, by the way?
105 over 512. And that would be 1024 over here as well. This is going to be 210 over... Yeah, okay, so both ways you could think of this.
Oh. Bird.
105 over 512.
That's okay. This is a cool problem, though.
It is. It is. Just 2 to the 10th. Sloppy mistake.
I don't like it.
I'm going to go back to the footage and see when I first figured out my fingers what I did wrong.
Well, I think me blurting out 20 billion didn't help.
I don't think it... Yeah, it probably didn't help.
No, it didn't help.
It definitely didn't help. It might have hurt. Eric TLT!
We're doing well.
We are
We're also
literally
doing good.
living the dream right now, is what we're doing.
We're living in a dream.
No, we're living the dream.
Right. Your dream right now, that's where we are.
Yeah.
You're dreaming. You're asleep. Don't move.
Good.
Just breathe.
Just breathe. All right, Levi, what are you doing? Dangling modifiers?
What is this? Oh, that's so cool.
Yep, got it recently.
Doubt it.
Got one
Okay.
for my MacBook too.
Mine is a Band-Aid.
I know. I've seen it.
Yeah?
Yep.
Yes. Okay, so Eric, we're going to now not do... So Eric was one of the people who was talking about probability. This was for you, but then you were in here. And
You can always watch it afterward. Just don't
Yeah.
expect us to answer your questions because they won't be
Ever
live.
again.
Ever again as well. Until the next stream. Or now.
Well, now.
Yeah.
Or before. We can answer your old questions as well.
Yes.
We're going to do dangling modifiers. Do you know what a dangling modifier is, Eric?
Yeah,
TLT?
Eric. Do you know what a dangling modifier is? Psh, Eric.
We should just bully all over yours.
Especially Eric. Who wants to see probability and then shows up late? What are the chances of that? Knowing Eric, they're high.
You'd be a terrible bully.
Yeah. I was good at bullying.
Were you?
Yeah, I once tripped a kid and I felt terrible about it.
That's what I'm saying. I'm saying you're bad at bullying.
Yeah, I later invited him to hang out, like, later that day, because I'm like, I can't live with myself.
Did he say no?
No, he hung out with me. We were, like, friends. So you shouldn't trip your friends, and I tripped him.
Right.
Yes.
Did he become your friend? Because of
No, we were already friends. I don't know why. It was part of me was just like, oh, I think he'll think it's funny. And he fell to the ground. And it's like, that's not good. All right.
No chance.
Right.
My iPad. Huh? No, that's mine. That's mine. That one's mine.
Nope.
Oh. Dangling modifiers.
Oh, man.
Eric, we may have talked about this with you, but I forget. If we have something like, this is the basic one that I normally do. Running down the street you have two options here. So running down the street, a rock tripped me. Okay, so we haven't done this. Running down the street, a rock tripped me. Or, running down the street, I tripped on a rock. Which one of these is wrong? Don't answer which is right, just tell me which is wrong, and can you tell me why it's wrong? This is a relatively uncommon question type on the ACT and SAT, but it is very likely to show up. Not every test, most tests. 2, is that wrong? 2 is not wrong. 2 is correct. Number 1 is wrong. Yes. Okay, yeah. 1 is wrong. Why is 1 wrong? I almost called Eric Bird, but that's you, Bird. I'm sorry. Why is number 1 wrong? Oh, it's cold in here, Bird. Yes. Okay, so we'll just deal with this. Running down the street, we don't have our subject here, right? We don't have a subject, and that's fine. We don't have to start the sentence with a subject, but let's talk about this comma here. Let's start in there. That comma is a non-essentials comma, because running down the street doesn't modify a rock tripping you, but you can say that while you were running down the street, you tripped on a rock. Exactly. So this is a non-essential, right? That's what type of comma we have here. So this non-essential has to describe something right before it, which doesn't exist, or something right after it. That or I, right? You're a subject of the sentence. That's what this non-essential describes. That's no good. It can't describe a rock. And as you said, you can describe yourself that way. So these aren't so hard once you realize you have them, but they are very hard to recognize a lot of the time, because many times this part of the sentence is not underlined, and you just have this as what you're allowed to say. You know, these are your A and B, and then C and D are other things. So the recognition for these, most of the time, most of the ones I've seen, definitely in the, just to clarify, is a rock tripped me an independent clause. Yes, it is. So you can definitely say that whenever you want. A rock, that's your subject. And then tripped is your verb. And then me is technically an object. Not that that really matters too much. Okay? So, yes, you can just have either one of these, but this determines which one you're allowed to say. So to recognize these problems, you're always looking at the answer choices first and seeing what's going on. If you see a bunch of commas or dashes or semicolons or things, that's what you're dealing with. Independent clause stuff and finding out how to separate things, all that. I get confused on subjects and verbs sometimes. Okay, with confusing subjects for verbs and vice versa, or just when something's a subject and not, when something is a verb and not. Is that what you mean? I just asked 2 questions, so yes or no is not going to suffice. Do you mean you mix them up together with each other, subjects versus verbs, or you just have trouble identifying each one on their own? Just say more specifically what you have trouble with. Don't answer my question, because I've asked 7 at this point.
Just say yes.
Just identifying. Okay, cool. So the subject, they're tied together. So in this, there is a verb here. Running is a verb, but it's not the active verb in the sentence. So the subject and verb go hand in hand, and they have to make sense. They have to be and think active. What is actually happening in this sentence? Not necessarily right now, because you could have past or future tense, but what's the main kernel of the sentence? What is actively happening? Running down the street. That's ongoing, but that's not the active verb in the sentence. The active verb in the first option, which is wrong, but is tripped. A rock tripped me. Running down the street, a rock tripped me. Running down the street, I tripped on a rock. So subject and verb. They have to be active. So if we say, that's that's the man I met yesterday. Where is your subject? That's not how you spell that. Where's your subject? Where's your verb in this sentence here? That's the man I met yesterday. Yesterday. I don't know why that's hard for me to spell. Because I'm going to switch I'm going to blow this up to that is. So, yes, I would never be a verb because I is a noun, or sorry, it's a pronoun, so it would have to be the subject or object or something else of the sentence. In this case, no. So this could be a subject, this could be a verb, but these are modifying man, right? That's the man I met yesterday. So this is describing this guy. So it's not a non-essential, but it's not the active clause in your sentence. It's not the independent clause. This is the independent clause. That is the man. Okay? So this is your subject. This is your verb. That is the man I met yesterday. You could also put in whom here. So that is the man whom I met yesterday. Is the verb. Yes. To be, the verb to be. Is. That is the man I met yesterday. He is the man I met yesterday. You could say he is also. This is hard. This is hard. So it's not. There are always a lot of words that could be your active verb, and there's always a lot of nouns that could be your subject. But you got to pick the pair of them that are the active ones. Yes. So I tripped. A rock tripped me. A rock tripped. That is. This is subordinating. It's describing man. It's not the main kernel of the sentence. And it's often used in this way that's confusing, is when it's subordinate to something else. Are they always right by each other? No. Okay, so here, Eric, where is your subject and where is your verb? You have a bunch of commas. Yes, good. TLTHS is the high school you attend, just so you know. So yeah, this is all a non-essential. Good. So your subject is not going to be in there. Eric studies. Perfect. This is your subject. This is your verb. So Eric, a student at TLTHS, studies for the SAT, a test that he loves. Hates. Non-essential. Very good. So whatever you want to say, loves, hates, whatever. This is a non-essential as well. This non-essential describes SAT. This non-essential describes Eric. Good. Now, you have a pronoun here, right? He loves or he hates or whatever. That could be the subject and verb pair for some other sentence, but not in this one, right? Because it is part of the non-essential. It's describing something else. It's not the main active subject-verb pair. Yes? Does this make sense? Because this is very important. It is easy to get confused where your active stuff is going on. Are you happy with this aside from the truthfulness of the statement? Very good. Awesome. So, I have no idea where I was. Let me give you another one of these dangling modifiers ones. Hey, Braid.
Yeah?
Can you come up here?
Yeah.
So I noticed that, and I think Eric was about to point this out, but down in the bottom left-hand corner, there is this blue thing.
Oh.
What do you think that is? Because I don't think Eric knows.
Right. Well, Eric, that's Alta Ipsum, and it's one of our sponsors.
Yes, you are contractually obligated to listen to us talk about Alta Ipsum.
Alta Ipsum in Latin, loosely in a very flabby way, translates to summit yourself, which means, you know, get to the highest point you can of yourself, do the best you can.
Very hard with all the flabbiness of it.
Yes, of the translation.
Yes.
It is an application that you can download on your smartphone or on your computer that lets you track your grades, plan your academic goals or other life goals, and also make yourself a scheduler. Alta Ipsum is a loose translation of summit yourself. Eric just asked.
Also, it will make you coffee. It made me coffee once.
Really?
Yes.
Wow. And was that during the free month?
No. So after the free month, it will begin to make you coffee.
Eric TLT, this will absolutely help plan your test studies. If you tell it you have a test on a certain day, it'll block out like 3 events saying, okay, study 20 minutes today for the test, and then 2 days later, study 20 minutes today for the test. So all you have to do is just follow what Alta Ipsum tells you to do. And also, there'll be a free trial that I can use to see if I like that. Yeah, why not? I think we could probably throw in a free month if you like.
Throw in a free month.
Yeah,
that's what you're into.
A free month, but only for you, Eric, because you suggested it.
Yeah.
Yeah. Eric, you've got to try it. I mean, you know more about Alta Ipsum than most people at this point.
Probably than the founder.
Probably than the founder, yeah. Hey, you want to show them our other sponsor?
Yes.
Our other sponsor is Tight Bond Original Wood Glue, because Levi and I have a Tight Bond.
Okay, so next one, let's do a little diggity dance. Bird, you have a child? Oh, not that soon. Okay. Eric, it's like you know what's going to happen. Did you know that Eric spends 99% of his time watching our stream?
No.
No? Hey, Chameleon Gaming. Didn't see you for a while.
Chameleon just subscribed on YouTube.
Chameleon Gaming just commented. Chameleon Gaming, do you have any questions about the SAT, ACT, or Brady's personal life? Brady's the other person who's not on screen. Whoa. I haven't seen you in a month.
My flight got canceled tonight.
Oh, what a terrible day.
You guys want one?
Yes.
Sorry, Brady. That's fine.
Okay, Chameleon Gaming, do you have any questions about specific stuff? Oh my gosh, is there jelly in here?
No, sorry.
Do you guys want any?
You want to
No, I don't want
nuts?
This is probably a terrible place to do this. Hey, Bird.
Yeah.
Don't eat my donut. I'm not going to.
Running down the street. Oh,
Mm.
Dangling Modifiers.
Yep.
All right,
Okay.
I'm gonna go to my room now. Was it good?
Yeah. Yes.
You didn't eat it, did you?
I licked the sugar off my
Why was your flight
thumb.
canceled?
Bursting into the room.
They rescheduled?
No.
I'm really bad test taker. Anything you could help with? Yes. Lots of stuff.
So you bought another-
Yes. Brendan. Yes. Yes. Everybody. Yes. He's our intern. He just gets us donuts. We send him to flights we never actually.
Another
booked.
roommate?
And then- Also, so Chameleon
This
Gaming.
is they forgot about me.
Eric
Wow.
is new. Eric is new.
Okay.
Chameleon Gaming. Yes, we can help with tests, but specifically the SAT and ACT.
What he said.
So not other stuff so much.
Well, I can help with tests, but I don't work here anymore, so
Yeah.
we can't do it.
Yeah. Bursting into the room.
Brendan.
We can say
I was trying to do.
Brendan
Kramer.
gave
I've been watching that show recently.
out donuts.
It did.
Or ACT. Yes, lots of things. Okay, so
I'm
hey,
joking, actually. You should.
I will get to that. Let me just give another option. We'll talk about it, and then I will answer that. So don't go anywhere. If you go somewhere, you'll never be able to find us again. Just be careful of that.
You asking about me?
He's asking if you know about alta ipsum.
Do you mean, help me out here, in Greek, reaching the peak?
Latin.
Summoning yourself. You're a mess.
Somebody, there's a reason I'm no longer. They kicked me out.
Brendan gave out donuts, or we ate Brandon's donuts. Donuts in this case. Downouts.
Like little butt.
Downouts. There you go. Okay, aside from the misspelling of this word, the problem... Yeah, so Brendan does know about alta ipsum. Yes, since you were asking. We want this one, right? Because Brendan is the one who burst into the room. Okay? Yes. Brendan is the one who burst into the room. Now, we could have also burst into the room. Grammatically it would work, but that's not what happened. So, whatever the SAT or ACT shows you, you have to do that thing. Obviously, they don't show you anything. This is not a question you'd actually get. Okay. Very good. Eric TLT, you are on it like butter on pancakes. Look, I have very productive metaphors most of the time. This happened to be a pretty unproductive metaphor. Okay. Chameleon Gaming, assuming you're still here. Yes, we do ACT stuff. If you go to our... Yes, we do. That's very true.
They used to SAT. SAT.
Oh, Brendan.
Now we act.
Brendan, since you stopped, they actually stopped giving out the SAT.
It's probably for the best.
They said they weren't. Yeah, they weren't making enough money.
Didn't we run the numbers on it?
Yeah, at some point we did. Okay, so Chameleon Gaming.
Tens of millions.
We do ACT stuff. I'm not gonna just throw super general advice at you, just because it's not gonna be that useful for you. Have you taken any ACTs before? Do you know where your strengths lie? Can you find them and mail them to us? Hey Bird.
Yes.
Can you come up here?
Yes.
I'm a little scared because Chameleon Gaming is new and I'm just a little uncomfortable.
Why do you always want me to come up there?
I want you to come up here.
It's like you want me.
Maybe you should put learning better metaphors into alta. Okay, Eric.
Is Eric giving you a hard time?
Eric is giving me a very hard time.
Eric, give him a softer
Give
time.
me just at least if it's furry.
Yeah, a soft, furry, you can kind of pet it. That kind of time.
Yes.
Chameleon game.
Something with a snout.
What is...
Yes, 3 times. Okay. So where were the issues? Was it timing? Was it the English section specifically? Was it did you not... Yeah, no, I don't want to ask that question. Never mind.
Yeah, you shouldn't have asked that question.
I didn't ask the question.
You didn't, yeah, exactly.
It was a question that was in my head. Will never leave my head.
Chameleon gaming, you kind of like
nobody knows who Christopher Walken is.
No. You like shift your colors or something? That's not a good one. Chameleon, do you shift your colors because you're a chameleon? You play games in a couple different characters so people don't know who you are? Math pretty much is what he says.
Math, pretty much. Yeah, let's do some math. Eric loves math.
Math.
Eric and math are actually getting pretty serious.
Maths, really?
Yes.
Eric's personal life, a lot of math.
Mm-hmm. A lot of math.
That's pretty exciting.
Yep.
Is he going to pop the question?
Math in Eric's personal life actually means summit yourself in alta ipsum.
The language of alta ipsum? Yes.
Greek means summit yourself in alta ipsum. Okay, so what kind of math are we talking? Are word problems
adding numbers, subtracting numbers,
dividing,
taking the reciprocal of fractions. Flip the fraction, change the sign.
flip the traction.
Flip the traction. Christopher
Crush
Walken. Christopher Walken. Walken. Not
Yeah.
walking. He's been walking. He's not currently walking though. Yeah,
The pun waiting to happen.
Chris Walken. Everyone's made that pun. Don't think I haven't heard it
Okay.
so many times in my life.
Okay, so math specifically, do you? We did probability earlier in the stream.
It was really hard.
It was super hard.
We figured it out though.
Yeah, it was like the time that Eric gave me. We can talk about anything you want. I mean, there's a ton of math. What's a good thing to talk about?
Look at my
math-wise?
hand. Oh, my big blue rectangular hand. Oh, now it's brown. A good thing to talk about?
Yeah.
I think I just have a problem with word problems. That's what Chameleon says.
Okay. Is it
Wait, he's got a problem with word problems.
Anything is good.
Anything is great. Should we put up an overlay? Let's find some word problems.
I don't think we've had an overlay for the math section.
Really?
We don't have an overlay for the math section.
Wait, we used to have one.
No.
Did you take it down?
Did you have it on Friday?
Oh, Eric's got some scores for you. Yeah.
There's no math.
No, it's at the end.
Dude, stop it.
Is there another one here?
No, it's the same thing. It's just the bottom half of the page.
If we keep going, we'll find it.
Bird. Okay, we don't have an overlay for math right now, but we can talk. So we can't do word problems super well.
We can find some.
Let's do.
Yeah.
Will you?
What? There's comfortable chairs over there.
4 more than twice the square root of a number. Yeah, that's okay with us.
Yeah, we're fine with
You're
that.
allowed to do that.
Yeah.
You did it, so it's probably better to ask forgiveness than permission.
Right.
Yeah. But it's much better to actually permit forgiveness.
I had to think about that for a little while.
No.
Okay, I've thought about it. Come on, let's get going.
I'm
Is-
trying.
is 7.
Is 3 times that number.
Oh. All right. Mumber? Is that what you're going to say,
I
mumber?
was going to say Munber.
Chameleon Gaming, this is a literal word to math translation problem. All right? You cannot think through what the answer is going to be. It's not going to happen.
I'll let you do this.
Yeah, no, I know. We know that. Yeah, those are okay. That's fine. It's fine to get those scores.
We're just messing with you.
We're just
Evan.
messing with you. Exactly. So what you want to do with this is turn it into a math equation. Best thing to find first is where your equal sign would be. So there's a word in this that basically means the same thing as equals. 4 more than twice the square root of a number is bing, bing, bong, bing, bing, bong. Right there, that means equals. So is means equals. Let's do this one a little bit. 3 times that number. All right, so there's some number they want us to find. A number, that number. We don't know what it is. So in these situations, we use a variable. That's the thing we're going to try to solve for. It stands for some missing value. So 3 times that number. What would 3 times that number be? That would be 3 times our variable, which is going to be 3 times x, which is 3x. Okay? Now, let's figure out right here. So Eric TLT, it looks like you took the square of x. You squared x. You read it wrong. Exactly. Good. All right. So 4 more than... The way to find 4 more than something is to add 4 to something. So we're going to say 4 plus twice the square root of a number. All right, this number is x. Finding the square root of a number is the square root of x, and twice that would just have a 2 out in front. So 4 plus 2 times the square root of x is equal to 3x. That's what this would mean as a literal algebra problem. Okay? Chameleon Gaming, does that make sense? Now we're actually going to solve this thing, and it's going to be awesome. 4 more than twice the square root of a number is 3 times that number. Okay? Now let's solve it. Well, we have the square root of x in there. All right, that's a radical. This has a radical in it. We got to get rid of that radical. The way that you get rid of a radical is the first thing you do is isolate the radical. All right, get it by itself. Take the radical, put it in the Ecuadorian embassy in the middle of London, and keep it there for 7 years. Isolate the radical, okay? Pretty good, right? Yeah.
Oh, God.
I didn't think you watched the news or even read it. So I'm going to get rid of this 4 first. So 2 times the square root of x is going to be equal to 3x minus 4. Fantastic. Almost done. Let's take the square, or sorry, let us divide by 2. So we have the square root of x is equal to 3x minus 4 over 2. The way to solve this radical now is to square each side. That is the advantage to isolating the radical. Is then you can completely focus on that thing and get rid of it by doing the opposite operation, which would be squaring. So we're going to square both sides. And things are going to get kind of funky. Kind of funky. All right. Square root of x squared is going to just simplify to x. This side's going to be a little more crazy. All right. We're going to apply the square to the top and bottom because it's a fraction with, inside parentheses. So 3x minus 4 squared. We have to FOIL that. Okay. Don't forget to FOIL that. That's going to be 9x squared minus 24x plus 16. And we have to also square the bottom, which is going to be 2 squared, which is going to be 4. Okay? Let me know if that doesn't make sense. I didn't really walk through the foiling, but this is 3x minus 4 times 3x minus 4. And that's what's going to give you this thing up here. Okay? Now, we got to get rid of this fraction here. We got to multiply by this 4 to get it to the other side. All right? 4s are going to cancel. So we have 4x is equal to 9x squared minus 24x plus 16. This is a quadratic. We have x squared in there. All right, if you're going to solve a quadratic, there's a couple ways to do it, but the first thing you always have to do is get all the terms on the same side and 0 on the other side. I'm sorry, I gotta go. I have Ken, but thank you for the help. I saw your ad on Insta, and I like what you guys are doing. I'm going to keep watching your stream. Hey! Our advertisement on Insta. That's it. That's what we like.
Yes.
Yes. Well, that's okay. Good. That means it's working.
We actually
okay.
saw you on Insta. We were watching you as we were tutoring that live.
Yeah, we were. Yeah,
Yes,
we were able to see
live.
through our Instagram advertisement.
Yep.
Eric TLT. I've done a lot of foiling in my days, so I just know this is going to be 3x squared is going to be 9x squared. The negative 4 is going to become a positive 16. 3x minus 4 is going to be negative 12x, but it's going to be double that, so it's going to be minus 24x. Don't do it in your head. Do it on paper and just make sure you get the right answer.
Yeah, or ask the proctor when you're taking the test.
Yeah, proctors love that.
Yeah.
All right, so now we have 0 is equal to 9x squared minus 28x plus 16.
Wait, is this still the problem that I gave?
Yes, we're solving it.
Wow, that's very exciting.
We're solving it.
This
Exactly.
is not going to be pretty.
That's going to be fine. Okay, is there anything we can take out of all of these numbers? Any greatest common factor? 9, negative 28, and 16?
3,
no.
my lord.
No, you can't take 3 out of these. Okay, so now it means it's time to either factor or do the quadratic formula to solve this. All right, these are some kind of large numbers. And Levi just made this up. The chance that this is factorable, it could be, but I'm going to guess it's not. So let's not even try that.
3 below.
No, not 3. So we have to do the quadratic formula.
If it's 3, will you give me money?
Yeah, not a lot of it though. I'll give you $3.
Okay. Really?
All right. So x equals minus b plus the square root of. Oh, geez, it's a big number.
I'm just checking if 3 works. 9, 81, 60.
It better not work.
No, it doesn't work.
Yes. So b squared would be. This is a long problem. Wait, you can ask them questions while doing the SAT? Can I also use a phone? Yeah, you can also bring your math teacher in.
Bring Alta Ipsum.
Yeah, Alta Ipsum's your bud. Minus 4 times 9 times 16. It's going to be 208. This is going to be 28 plus the square root of 208 over 18.
Eric TLT is going to get wrecked when he's going to cheat 7 different ways.
Oh, yeah. There's a little simplifying the radical we can do here. So 208 is divisible by 4.
Yes, 52.
No way.
Yes.
52. 20, and 52 is 26 times 2, so 13 times 2. Oh, there's another 4 to take out of it. All right, so we could have taken 16 out of 208 in the first place.
But you can't take out...
Yeah. So this is going to be 4 times root 13 over 18. Divide all these things by 2. 14 plus or minus 2 root 13 over 9. That's the number that Levi was thinking about in his head.
Yes, 14.
Who is
plus
smarter
minus.
with the SAT, Levi or Brady?
I think the SAT is smarter.
Yeah, definitely. Yeah. I will bring you in. Who is smarter with the SAT, Levi or Brady? Yeah. I think the answer to your question is definitely definitely both of us are smarter than the other. You can put that away. I don't want it. It's not going to fit. It's not going to fit. I don't want it. You can't give it to me. I don't want it.
Where are you going?
I have to sit down.
Why?
Because it's our stream.
You hate sitting.
That's just not true.
I'll erase this. Okay, Eric, we got 15 minutes. What do you want to talk about? Math, English, science, not science, you don't do science. Math, English. Math, English. Eric, do you have any, oh, you want to do, do you want to do some, just go through the essay? Oh, actually, okay, reading, all right. The SAT reading is going to be a little tough right now, but we can talk about it for sure. If there's a specific question on one of the SATs, then we can probably see it ourselves and then talk about it with you. You want general stuff? You want, a specific question type to go over? We talked about the two-part questions. We've talked about vocab and context. I think you've seen those streams for sure. We could do, no, we did purpose questions recently. I think you saw that one too. That's most of it. What do you want to do? I have tons of math that I didn't know on Khan Academy. Oh, there you go. Is that the blowing smoke out of your nose or whatever emoji? I can't really quite see it, but I assume that's what it is. Yeah, what do you want to talk about? What if you don't know the specific questions, you can talk about or ask us the realm of question. We'll make one up. Can we start from the hardest reading to the easiest reading? Yeah, you mean passage-wise? What do you want to do? I can pull up the test on my phone. We just don't have the overlay for it. Wait, no, we do have the. What am I saying? I'm so sorry. Of course. Yes. I don't know why I thought that. Okay, so hardest. We have this one. Okay, this one's hard. The census one isn't too bad. You want just like hardest questions, understanding wise. Got it. Okay. Sorry. Question types, or just individual questions on this particular test? We can pull up. I'm just looking at the question types I could go over. Okay. Any questions you think are harder? Great, sure. Let's do it. Best summarizes, according to the passage, members of... I don't know. Off the top of my head, I haven't looked at this passage in particular in a little bit, but let's try 14 and 15. So it's a two-part question. Let's just do a two-part question together. So we have, according to the passage, so we don't care. Well, yeah, of course it's according to the passage, so whatever. Which choice best describes the current financial situations in many major American cities? So financial situation in major American cities. Definitely needs to be American. I don't know how much of a thing that is or is not in this passage. Probably going to have to erase those lines. That's what we're looking for. Let's look at the line numbers. So we're looking for the answer first and then answering 14. Right? We're not just trying to pick one here. Okay. Yeah, this might be tough. I'm not sure. I think these questions get easy pretty quickly when you're going through this, or at least easier. So 36 to 39. Let's check those. 36 to 39. Nope. 36 to 39. We have America's major cities face enormous fiscal problems. Wow, that sounds pretty good. Many of them the result of public pension obligations they incurred in the more prosperous years of the past 2 decades. Okay, that seems pretty fantastic, actually. Enormous fiscal problems. Fiscal means money related. Right? What's the technical definition, Bird?
I will look it up. I will look it up now.
Okay. Which choice best is... Yeah, so it said financial situation in American cities, so that's exactly what 36 through 39 said, so great. 43 to 40... Yeah, sorry?
It means relating to government revenue, especially taxes.
Oh, so it's government specific.
Yes.
Okay, great. All right. 43 to 44, then 44 to 46. Oh, wait, no. I wanted to go there. 43 to 44, so we're here. How the cities are going to solve this problem. Oh, how the cities are going to solve this problem, I do not know. No. Okay, that doesn't talk about the current financial situation of cities. It's talking about a problem, but it doesn't tell us what the problem is, so it can't be good evidence for it. Then 44 to 46, we have what I do know is that if fiscal crisis were going to drive affluent professionals out of central cities, it would have done so by now. That is an if statement. I don't think it tells us about the current financial situation in most major American cities. So I don't like that one either. So B and C are no good. We don't like B, we don't like C. Or I don't. And if you disagree, please tell me why. So B is no good, C is no good. And then D, 48 to 51. Let's check that out. Oh, right here. Okay. The truth is that we are living at a moment in which the massive outward migration of the affluent that characterized the second half of the 20th century is coming to an end. Okay. Talks about migration of the affluent people, but doesn't quite say where, doesn't quite say most major American cities, whereas if we go back to these lines here, America's major cities face enormous fiscal problems, many of them the result of public pension. Okay, so major fiscal problems. So we have problems, we have many of them are the result of pension obligations incurred during more prosperous years earlier. So we know that all of these answers are terrible except for A in 15. And now let's look at 14 again. Expected tax increases due to demand for public works. No, public works is not supported in those lines. So I don't like public works. I don't want to. Let me make it go away. Go away, go away, go away, go away. There we go. Economic hardship due to promises made in past years. Obligations, promises. Okay, I don't love the word promises. It's a little vague, but whatever. I'm going to leave it. Greater overall prosperity due to an increased... No, so they talked about prosperity, and they said prosperous, but this is now talking about current prosperity. And then increased inner city tax base. That's just not supported. So none of that is supported. And then D, insufficient revenues due to a decrease in manufacturing. I mean, possibly that's a reason, but I don't like manufacturing. So be careful. You could make the, some assumption and jump to D. That's maybe the reason. But remember, this is not the test that you're taking in a normal reading class or an essay question where you're saying, how could these things have linked together? You're not trying to link too much stuff. You're doing exactly what they tell you to do. So A in 15 supports B in 14. Ended up not being a super hard problem, I think. But I don't know. This could end up being a hard problem for whatever reason if you're not doing it in that direction, going beginning and backwards. Yes? Okay, let me erase that and look for some other hard problems. Ow, whoa, whoa, whoa. Chart stuff? Do you want to do chart stuff, Eric?
Yes.
Would you be into chart stuff?
Yes.
Bird, you're not Eric.
I am Eric.
Oh,
I've always been Eric.
that would be super sad. And impressive, but also very sad.
Right.
It's just a whole consciousness that never existed.
Mm.
I'm having trouble with the following. Constants solving linear equations and linear inequalities graphing linear equations. Okay. So yeah, let's do that stuff. Graphing. We got 5 minutes. Yeah, so graphing stuff. Can you graph that? That's where I want to start. Probably doesn't look too complicated. But that's not really what I care about right now. We will get this. This can get complicated very quickly. Okay, great. So you can graph this, so I'm going to graph it real quick. We are going to have a y-intercept of 1. We have a slope of 2, so we're going to go... Great. Awesome. So you have that stuff.
I'll give you a slope of 2.
Will you?
Yep.
Where?
Right
We
there.
don't condone violence.
After that, can we go over multiplying matrices? You're going to love that. I don't know if you have time, though.
We won't have time, but we can do it tomorrow. We can make that the thing tomorrow.
Yeah.
You want to do multiple
Definitely.
matrices? Okay.
All right, I have a child.
Okay. Have a good session.
Thanks, man.
Did I tell you about my child before?
Huh?
Before this? Oh yeah, I told you about her. Never mind. Okay. All right. So you have this, and you know the y-intercept. The reason this is the y-intercept. So we got to talk about intercepts and just how to understand these equations. And one of the things that people forget is that it also remind us, because we might forget about the matrices tomorrow. People forget that you can plug in values. This line, every single point on this line, these infinite number of points can satisfy this equation. You have two variables in one equation, therefore there are an infinite number of solutions, but not all solutions are, not all xy pairs are solutions, but we do have an infinite number. So we know that this is the y-intercept. We know it's the y-intercept because what is the x value at this point? It's 0, okay? So that's why we know this is the y-intercept, because in this equation, the way this is set up, if we plug in 0 for x, we will be given the y value at that x value. So we plug in 0 for x here. This just goes away because it's 2 times 0. We just get y equals 1. So y equals 1. So therefore, 0, 1. That becomes our y-intercept. But the same thing works for the x-intercept. So at the x-intercept right here, we know that the opposite of this is true, so the y value is 0. So if you're asked for the x-intercept, you always plug in 0 for y. That is how you can figure it out. So in this case, we're going to have 0 equals 2x plus 1. We subtract 1 from both sides. We have negative 1 equals 2x. So we get x equals negative 1/2. Which makes sense if we look at this point here. It's not perfectly drawn, but it's halfway between 0 and negative 1. That's where we get the negative 1/2. So that point there is negative 1/2, 0. I'll write that down. Negative 1/2, 0. This also works for parabolas. If you have a parabola that, let's say, looks like... put it here. It's going to go sort of like that and sort of like that. Okay? So that's our parabola. And I'm going to say that it is y equals x minus 2 squared minus 1. Okay? That is the equation of that parabola. Now, I want you to find what these x-intercepts are. It looks like they're going through the points 1 and 3, but we have to make sure. The same situation applies to this as did to this. If we're looking for x-intercepts, you always, always, always remember this. If you're looking for an intercept, you can find it using the equation if you plug in 0 for the other variable, right? We're looking for an x-intercept. The y value isn't anywhere, so it's 0. So that means we plug in 0 for y. This is why factoring happens most of the time. It's because your y is 0, and then you're solving for x. Because factoring, when you get your factored form, then translates to your x-intercepts. It also is called solutions and zeros and things like that. This is why you always want to have the 0. So y equals 0, and then we just have x minus 2 squared minus 1. So we can solve this two different ways. I'm going to just FOIL this out, put the negative 1 in, and then factor it from there. So this is 0 equals x, I don't need the parentheses anymore, x squared minus 4x plus 4 minus 1. So this is 0 equals x squared minus 4x plus 3. So I'm going to factor this, and that will be x minus 3, x minus 1. So now we know we set each of these equal to 0. So x minus 3 equals 0. So x equals 3. And x minus 1 equals 0. So x equals 1. So when y equals 0, we get x equals 3 and x equals 1. That makes sense according to this graph. Bam, bam. Okay? So this is a... Oh, sorry, I did... Neutron, I thought you were Eric. My bad. If you're still here, hello. I should have welcomed you. But yeah, we'll do matrices tomorrow. Does this thing make sense? So this is obviously not everything to do with graphing, of course. We didn't get to inequalities yet. We can also do that tomorrow if you ask again, Eric. But this is a super important concept. You can get what you want if you have the given equation. If you want intercepts, you plug in 0 for x to find the y-intercept, 0 for y to find the x-intercept, right? The opposite variable. And then you can find the slope this way. Put things in this form, y equals mx plus b, because you know what those pieces are, but you know this piece is the y-intercept because when you plug in 0 for x, this piece just goes away. You just get left with y equals that thing. But that doesn't mean you can't find the y-intercept if you're not in this situation. So if your equation looks like x minus 2y equals 3, and you're asked for the x-intercept or the y-intercept, you just plug in 0. So for the y-intercept, we don't have to put it in y equals mx plus b form. We just plug in 0 for x. So we have 0 minus 2y equals 3. We divide by negative 2. We get y equals negative 2/3. Okay? So this is one piece. We can do more stuff. We will do more stuff tomorrow for sure. But it's super important to realize that these equations are very, very, very adaptable. You can use them in a lot of different ways. Plus, drawing things generally helps. You can visualize stuff. You also got to be comfortable at some point with graphing this. From scratch. Can you put this on there, and can you go from here to there? So all of that stuff is helpful. We will go over all of that. Maybe not all of it, but lots of it tomorrow. There's tons of stuff. But it's fun. It's kind of fun. I don't know. Okay. I'm going to say goodnight, but see you tomorrow, Eric, and hopefully Neutron 627. We can see you as well. And everyone else. Have a good night.